Hello dear students, welcome to EPG Pathshala. Myself Dr. DC Saxena, presently Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am presenting you the paper Technology of Spices and Condiments. The present module, which is about the spice oil and oleoresins, its technology of manufacturing, and this will be explained to you by my co-author Mrs. Aarti, who is well versed with this subject.
Hello students, welcome to EPG Pathshala. I am Khan Nadia from Sant Longwal Institute of Engineering and Technology on behalf of Ms. Aarti. Today I am going to talk about Module 7 of paper number 10, Technology of Spices and Condiments. In this module, we will be learning about technology of manufacturing of spice oils and oleoresins. As we know, India is one of the topmost producers of spice oils and contributes to around 70% of the total spice oil production. Countries including USA, European Union, Japan, and other Middle Eastern countries are major importers of spice oil. The exports of Indian spice oils has been rising significantly in last few years owing to a sharp rise of demand in the fast food sector. Oleoresins are the flavor extracts obtained by the solvent extraction of ground spices. The spice oils are the oil distilled off from the spices at the initial stage before subject to solvent extraction. They have aroma of spice and possess the attributes which contribute to the taste such as pungency. There are different spice oil production methods which include steam distilled, solvent extract, cold pressed, hydro-diffused, and carbon dioxide extraction. With increased preference for quality products, use of spices is rapidly replaced with oleoresins and spice oils. In this module, I will talk about manufacturing process of oleoresin, type of oleoresin, method of spice oil and oleoresin preparation, paprika oleoresin and turmeric oleoresin, black pepper and ginger oleoresin, finally the conclusion. Spice oil is a spice derivative that are extracted generally by steam distillation process. The spice oils distilled off from the spices at the initial stage before subject to solvent extraction. These oils are the volatile components present in spices and provide the aroma and flavor of the spice they are made from. India is one of the topmost producers of spice oils and contributes to around 70% of the total spice oil production. Countries including USA, European Union, Japan, and other Middle Eastern countries are major importers of spice oil. The exports of Indian spice oils has been rising significantly in the last few years owing to a sharp rise of demand in the fast food sector. Oleoresins are flavored compounds obtained by solvent extraction of the ground spices. They have aroma and possess attributes which contribute to the taste like pungency. All spices contain essential oils in various proportions which can be extracted by steam distillation. Oleoresins are preferred because of their microbial advantage and uniformity in flavor and pungency, easy to store and transport. Further, they have several applications like preparation of beverages, soup powders, curry powders, confectionaries, noodles, canned meats, and sauces. Now, what are oleoresins? Oleoresins are flavored compounds obtained by the solvent extraction of the ground spices. They have aroma and possess attributes which contribute to the taste like pungency. All major spice oleoresins are produced by solvent extraction and supercritical carbon dioxide. Oleoresins have large domestic as well as export markets. They are consumed by broad spectrum of manufacturers like beverages, soap powders, curry powders, confectionaries, noodles, canned meats, sauces, poultry products, and so on. All major spice oleoresins are still being produced by solvent extraction. Over the years, there had been changes in regulatory requirements for the type of solvents and residue levels. The industry was proactive in upgrading the facilities for these requirements. Investment in the supercritical carbon dioxide extraction equipment is the way forward to keep up with the residual solvent regulations in future. This technology yields the benefits of a superior flavor profile, less thermal impact, and lower cost in use. This technology could replace steam distillation and solvent extraction at least in some spices in the near future in view of the overall cost benefits. Various types of oleoresin: Ajwan seed oleoresin, black pepper oleoresin, capsicum oleoresin, cardamom oleoresin, cassia bark oleoresin, celery seed oleoresin, cinnamon bark oleoresin, clove bud oleoresin, coriander seed oleoresin, cumin seed oleoresin, curcumin powder, date extract, and fennel seed oleoresin. Some more different types of oleoresins are Galangal oleoresin, ginger oleoresin, juniper berry oleoresin, mace oleoresin, nutmeg oleoresin, olibanum rice lode, parsley seed oleoresin, turmeric oleoresin, white pepper oleoresin, ginger oleoresin, and paprika oleoresin. Methods of oleoresin preparation. For each method, there may be many variations and refinements, and the extraction may be conducted under reduced pressure, ambient pressure, or excess pressure. The choice of extraction method will depend on the nature of material, the stability of the chemical components, and the specification of the targeted product. Steam distillation is a technique used to distill immiscible liquids for which steam provides one of the immiscible phases. The two substances mix in the gas phase and co-distill, but when cooled, the desired component separates from water as it's immiscible. Steam distillation is commonly used to extract perfume and flavor oils from natural sources. Now, coming to the methods of oleoresin preparation. Steam distillation and solvent extraction with continuous, single or multi-stage batch operations as required for optimal processing. The extraction process used here is supercritical fluid extraction method, which makes use of carbon dioxide as solvent. This technology is state of the art and is globally known. Moreover, it's environmental friendly as compared to the conventional method, which is based on hexane and organic solvent. The market price for the product obtained through this process is much higher as compared to the product obtained from the conventional method, as the former do not contain any chemical residues and the purity level is very high. Supercritical fluid extraction. In supercritical fluid extraction method, carbon dioxide acts as solvent. This technology is state of the art and globally proven. Moreover, it's environmental friendly as compared to the conventional method, which is based on hexane and organic solvent. The market price for the product obtained through this process is much higher as compared to the product obtained from conventional method, as the former do not contain any chemical residues and the purity level is very high. Number of factors determine the final quality of a steam distilled essential oil. Aside from the plant material itself, most important are time, temperature and pressure, and the quality of distillation equipment. Essential oils are very complex products. Each is made up of many, sometimes hundreds of distinct molecules which come together to form the oil's aroma and therapeutic properties. Some of these molecules are fairly delicate structures which can be altered or destroyed by adverse environmental conditions. So, much like a final meal is more flavorful when made with patience, most oils benefit from a long, slow cooking process. The temperature of the extraction chamber cannot be too high, lest some components of the oil be altered or destroyed. The same is true of the chamber's pressure. Lavender, for example, should not be processed at over 24 °F and 3 pounds per square inch of pressure. Higher temperatures and pressures result in harsh aroma, more chemical than flora, and lessen the oil's therapeutic effects. Also, the extraction period must be allowed to continue for a certain period of time in order to flush all the oil components from the plant, as some are released more quickly than others. Despite the drawbacks of aggressive processing, high temperatures and pressures are often used to produce large quantities of oil in a short period of time. These oils are usually destined for use in cosmetic and processed food manufacturing, but are sometimes sold to final consumers as essential oils for use in aromatherapy. These oils will be less expensive but are of limited therapeutic value, and the difference is apparent when the aromas are compared side by side. Water distillation. Water distillation is the simplest of three distillation methods. The plant material is mixed directly with water in a still pot. A perforated grid may be inserted above the base of the still pot to prevent the plant material settling on the bottom and coming in direct contact with the heated base of the still and chairing. Water distillation is probably the simplest and cheapest method of extracting essential oils, but the quality of the oil has the greatest potential to be modified due to the effects of direct heating and the water contact. Water distillation is a slower extraction process than other two distillation types and therefore less energy efficient. The only advantage of water distillation is the cost of equipment tends to be extremely low, and the designs of the stills, condensers and oil separators are simple, so they can operate and be maintained in very remote locations. The water distilled oils are commonly darker in color and have stronger still of note odors than oils produced by other methods and therefore tend to be of the lowest value. The disadvantage of the water distillation method would generally outweigh the advantage except for local market use. For manufacturing of oleoresins, raw spices are first cleaned and then ground to required meshing size. The extraction is undertaken with the help of proper solvent. The solvents that can be used are hexane, acetone, ethylene dichloride or alcohol. Extraction is done by percolation of the solvents at room temperature through a bed of ground spices packed in a SS percolator. The dark viscous extract containing not less than 10% of total soluble solids are drawn off and distilled under reduced pressure to remove the excess of solvent. The essential oil is obtained by steam distillation. Advantages of steam distillation. The amount of steam and quality of steam can be controlled. Lower risk of thermal degradation as temperature not above 100 degrees Celsius is used. Most widely used process for extraction of essential oils on large scale throughout the flavor and fragrance supply industry. It is the standard method of extraction. there is a much higher capital requirement, and with low priced oils, the payback year can be 10 years. It requires high level of technical skill and fabrication, and repairs maintenance require a high level of skill. Distillation is still the most economical method of extracting essential oil from spices and aromatic plant material. Advantage of distillation is that it can generally be carried out with some very simple equipment close to the location of plant production. Distillation is less labor intensive and has a lower labor skill requirement than solvent extraction. Adopting the simplest or cheapest extraction method, however, may prove to be false economy because of low yield, poor or highly variable oil quality, and low market value. Water distillation is the simplest of the three distillation methods. The plant material is mixed directly with water in a still pot. A perforated grid may be inserted above the base of the still pot to prevent the plant material settling on the bottom and coming in direct contact with the heated base of the still and charring. Water distillation is probably the simplest and cheapest method of extracting essential oils, but the quality of the oil has the greatest potential to be modified due to effects of direct heating and the water contact. The water distilled oils are commonly darker in color and have stronger still off-note odors than oils produced by other methods, and therefore tend to be of the lowest value. The disadvantage of water distillation method would generally outweigh the advantage except for local market use. Solvent extraction. Solvent extraction is used when the odorous properties of delicate flower and plant material would be altered or destroyed by steam or water distillation, or when a plant, for instance, rose absolute and jasmine, contains very little oil, making steam or water distillation impractical. Solvent extraction produces a concrete which in turn is refined into an absolute. To produce a concrete, the plant material is gradually saturated with a hydrocarbon solvent. The solvent dissolves the plant's constituents, including essential oils, fatty acids, and waxes. After the solvent is distilled off, the remaining constituents make up the concrete. The essential oil is extracted from other constituents with alcohol. The fatty acids and waxes are not alcohol soluble, so they are left behind. A secondary distillation then removes the alcohol, leaving the absolute oil behind. Oleoresins can be extracted by batch and continuous type of solvent extractor, as can be seen from figures. Absolutes. Some plants and particularly flowers do not lend themselves to steam distilling. They are too delicate or their fragrance and therapeutic essences cannot be completely released by water alone. These oils will be produced as absolute, and while not technically considered essential oils, they can still be of therapeutic value. Jasmine and rose in particular are delicate flowers whose oil are often found in absolute form. The processing of an absolute first involves the hydrocarbon solvent extraction of a concrete from the plant material, a semi-solid mixture of typically 50% wax and 50% volatile oil. The concrete is again processed using ethyl alcohol, in which the wax is only slightly soluble. The volatile plant oil separates into the alcohol and this mixture is removed. The alcohol is then evaporated and the result is an almost pure plant extract. Depending on the care taken in the evaporation process, sometimes 2% or less of ethyl alcohol may remain. The use of solvents in extraction process, notwithstanding absolutes, can have incredibly deep and complex aromas. Carbon dioxide and supercritical carbon dioxide extraction. Now, the most modern technologies are carbon dioxide and supercritical carbon dioxide extraction. Both methods involve use of carbon dioxide as solvent, which carries the essential oil away from the raw plant material. The lower pressure carbon dioxide extraction involves chilling carbon dioxide to between 35 and 55 degrees Fahrenheit, pumping it through the plant material at about 1000 psi. The carbon dioxide in this condition is condensed to a liquid. Supercritical carbon dioxide extraction involves carbon dioxide heated to 87 degrees Fahrenheit and pumped through the plant material at around 8000 psi. Under these conditions, the carbon dioxide is likened to a dense fog or vapor. With release of the pressure in either process, the carbon dioxide escapes in its gaseous form, leaving the essential oil behind. These carbon dioxide methods have a couple of advantages like steam distillation. There are no solvent residues left behind and the resultant product is quite pure. Like solvent extraction, there is no heat applied to the plant material or essential oil to alter it in any way. The oil produced is very accurate with respect to the original state of the plant. The carbon dioxide methods also are the most efficient, producing the most oil per amount of plant. One of the reasons for high cost of essential oils is the low yield of oil from plants. 1 ton of rose petals produces less than 1 pound of oil. The efficiency of carbon dioxide extraction is particularly important when rare or endangered plant species are involved, such as Indian sandalwood. Less of the precious plant is needed to produce an equivalent amount of oil. Cold pressing. Finally, there is cold pressing of citrus oils from the peels of fruit, as is done with bergamot, orange, lemon, and others. This method involves the simple pressing of the rind at about 120 °F to extract the oil. Little, if any, alteration from the oil's original state occurs. These citrus oils retain their bright, fresh, uplifting aromas like that of smelling a wonderfully ripe fruit. Paprika Oleoresins, also known as paprika extract, is an oil-soluble extract from the fruits of Capsicum annuum, lin, or Capsicum frutescens, Indian red chilies, and is primarily used as a coloring and flavoring in food products. It's composed of capsaicin, the main flavoring compound, giving pungency in higher concentrations, and capsanthin and capsorubin, the main coloring compound. Turmeric oleoresins. Turmeric oleoresins are extracted from Curcuma longa, a member of ginger family. It's obtained by solvent extraction of the ground spice, contains coloring matter, volatile oil, fatty oil, and bitter principles. It's orange-red in color and consists of an upper oily layer and a lower crystalline layer. Coloring components are curcumin and curcuminoids. It's fat and alcohol soluble, cold water insoluble. Commercially dissolved curcumin in polysorbate 80 or 60 to make it water dispersible. It has good heat stability and poor light stability. The color hue change with pH, greenish in acidic pH, orange yellow in neutral pH, more stable in acidic pH than in neutral or alkaline pH. Used in pickle, bakery, confectionery puddings, gelatin, gummy bears, yogurt, popcorn, and finger foods. Black pepper oleoresins. Black pepper oleoresin is the natural extract of dried tender berries of Piper nigrum and obtained by solvent extraction of black pepper, and the solvent traces are removed by distilling it in vacuum at controlled temperature. It's yellowish brown viscous liquid with pungent, slightly biting aroma. Packing can be done in HDPE bags, stored in full tight containers at controlled atmosphere and protected from direct heat and light. Ginger oleoresin. Ginger oleoresin is manufactured on a commercial scale in India and abroad and is in great demand by various food industries. The aroma of ginger is pleasant and spicy, and the flavor penetrating, slightly biting due to antiseptic or pungent compounds present in it, which makes it indispensable in the manufacture of a number of food products like gingerbread, confectionery, ginger ale, curry powders, soft drinks, vegetables, meat and fish curries, ginger cocktail, sauces, etc. ginger preserves, and ginger candy prepared from green or fresh ginger is quite favorite of many people and find great demand. A number of alcoholic beverages are prepared from ginger in foreign countries such as ginger brandy, ginger wine, ginger beer, etc. Garlic oleoresin. Garlic oleoresin is highly concentrated product obtained by solvent extraction and vacuum concentration of extracted juice. Methyl alcohol is the best solvent used for this purpose. Extraction time for this oleoresin is about 4 hours. Oleoresin from garlic is dark brown, soft aromatic extract containing 5% of essential oil. 1 part of garlic oleoresin is equivalent to 50 parts of fresh garlic. On steam distillation of garlic at 760 mm of Hg is decomposed to daily sulfide and other sulfides. Allicin intact in garlic is not bactericidal, but allicin is bactericidal dehydrated garlic. Now, what are the uses of garlic? It can be used as condiment for flavoring dishes. Garlic oil is used as an insecticide and it's also used as biofungicidal adhesive. Garlic residue is responsible for antibacterial property and garlic is also used for cancer prevention. Pepper oil. Pepper oil is obtained by dried crushed pepper berries. Yield of oil increases with maturity. Oil is concentrated in oil-bearing cells of the skin. 6 to 8% piperin is present in the residue. Piperin has got geometric isomers that are cavecin, isocavecin, and isopiperine. So, students, let us now summarize what we have learned in this module. All major spice oleoresins are produced by solvent extraction and supercritical carbon dioxide. The oleoresins and spice oils are preferred because of their microbiological advantage, uniformity in flavor and pungency. Further, they are easy to store and transport. They have several applications like in preparation of beverages, soup powders, confectionery, curries, noodles, sauces, and canned meat, etc. There are several advantages of spice oils. First, standardization. These oils ensure standardization in various products and hence are popularly used in pharmaceuticals, medicines, and chemicals. Second point is consistency. These oils have a consistent concentration of the spice they are made from and hence are more reliable. Third point is hygiene. These oils are manufactured using high technology machinery and processes, hence are quite hygienic. That's all about technology of manufacturing of spice oils and oleoresins. Thank you.
So, what is the technology of manufacturing of spice oil and oleoresins? You must be knowing what has been explained in this present module. Now, the next module will tell you about different uses of oleoresins under the Spice Soil and Oleoresins module. Thank you.